Welcome. This video takes a look at the rest of section 1.1 in the IB chemistry curriculum, and it talks specifically about states of matter, or what's also known as phase changes. So matter can be classified as one of four types. It's either an element or a compound, which are known as substances, or it's a heterogeneous or homogeneous mixture. So all four kinds of matter can exist in different forms or states of matter. Depending upon the pressure and the temperature it's under, we might call it a solid, a liquid, or a gas. And states of matter are characterized by the energy of the particles, which then determines the space between the particles and the freedom of movement. So what we commonly think of as the shape and volume helps us determine if it's a solid, liquid, or gas. So keeping that in mind, state symbols, S for solid, L for liquid, G for gas, and then AQ for aqueous, meaning it's a water-based solution, are often used to indicate the state of reactants or the state of products in a reaction. And the term particle is used generically to describe the many forms of matter can exist as, like an atom, a molecule, an ion, etc. The general rule is that as temperature increases, the kinetic energy will increase, which means the particles are going to speed up, which means they're also going to collide more and collide harder, and thus spread out. So solids are defined as having a fixed shape and a fixed volume with closely packed particles. So there's strong intermolecular forces holding particles in place, and that means the particles just vibrate within fixed positions, which is why it holds its shape, is because the particles aren't free to move anywhere else, but they do vibrate in those fixed positions. Gases at the other extreme spread out. In fact, they spread out so much they have no fixed shape nor volume. They have maximum movement, and the intermolecular forces are negligible. And in fact, if you think back to ideal gases, the intermolecular forces are so small that we consider them to be non-existent. Liquids then lie somewhere in the middle. They have a fixed volume, but not a fixed shape. So there's some intermolecular force there keeping them in the same area, but not so strong an intermolecular force that the particles stay in the same place. The particles can slide by each other or flow, but not free enough to actually leave the space. Kinetic theory, or kinetic molecular theory, states that the average kinetic energy of a system depends on the temperature. So kinetic theory helps explain why there are different states of matter, because it not only depends on the temperature, but it does also depend on what we call the intermolecular or interparticle forces. And so a fluid refers to a substance that can flow. And generally everyone thinks of a liquid as being a fluid, but it also includes gases, because gases flow too. In fact, they flow even better than liquids. We just don't notice it because most gases are not visible to us. But this explains why both gases and liquids diffuse easily. If you put creamer in your coffee, you see it diffusing or mixing itself, or if somebody sprays body spray in the room, quickly everyone can smell it. And you might remember from back in the day that kinetic energy, or Ke, equals 1/2 mv squared. And what that really tells you is that the energy depends not only on the mass, but on the speed that particles are moving. So this means light atoms are going to diffuse quicker. In a room, you've got the same kinetic energy or same temperature, so lightweight atoms or lightweight molecules will move much faster than the heavier ones. So phase changes is a name for changing your state of matter from a solid to a liquid to gas, or the reverse, or sometimes even directly from a solid to a gas, or from a gas to a solid. So as temperature and pressure change, or as at least one of them changes, matter can change states reversibly. Now, reversibly means that when you go from a liquid to a solid, if you change the temperature and pressure again, it can go back to being a liquid or being a solid. So phase changes occur at specific certain temperatures and pressures for each substance. And we give them the following names then: melting and freezing, I'm thinking you're familiar with; condensing, evaporating, and boiling are all between gas and liquids. And then sublimation is when you go directly from a solid to a gas, or deposition when you go directly from a gas to a solid. So here's a chart showing you the different phase changes. And when you're moving right, you either need to increase temperature or decrease pressure, or both. And to move left, so if you're from the right side, you want to go from a gas to a liquid or a liquid to a solid, you could either increase the pressure or decrease temperature, or again, you could do some of both. And as I mentioned, sublimation and deposition are unique because there's no liquid phase. You appear to go right from a solid to a gas. And the other thing we should note is evaporation is listed with boiling because they both result in a liquid becoming a gas, but evaporation happens much slower than boiling, and it occurs only at the surface and at temperatures well below what the boiling point temperature would be.